You think you're funny, do you?
Wagwan Ragamuffins. Today, we're going to find the area of a larger, complex shape by breaking it into smaller, more manageable shapes, finding the areas of those shapes, and then the sum of the partial products to get the area of the larger complex shape. And we're going to use that knowledge to help us figure out how to multiply a larger number, a two-digit number, by a one-digit number by decomposing the larger number into smaller, more manageable parts, finding the product of the smaller parts, and then getting the sum of the two in order to find the product of the larger number in the first place. Let's get to it. In third grade, we break apart or decompose numbers and we call it the distributive property. In this situation here, Laura helps sort books on library shelves, and she gets $25 an hour working for 7 hours. The question asks, how much money does she make? We know she works for 7 hours, $25 an hour. At the end, you will work out these problems, and the answer is going to be in the description. Let's start out by having a rectangle break apart 7 by 25. The horizontal axis, the top, is 2 10s and 5 1s. We'll break it apart for 10, 10, and 5 because I know how to multiply by 10s and 5s easily. The first rectangle is 7 by 10. The expression 7 times 10 has a value of 70. It'd be $70 in this case. The second rectangle is the same size, 7 times 10. The same expression, 7 times 10 equals $70. The last rectangle, the smallest one, is 7 by 5. You'll notice that the opposite side is the same length, 7. 7 times 5 is $35. The last step is to get the sum of the three partial products, 70 plus 70 plus 35. I'm going to work this out by looking at the tens first. 7 10s and 7 10s and 3 10s gives me 17 plus 5 175s. Now for the multiplication, 7 times 5 has to equal the same area. The three smaller rectangles equal the first one of $175. Here's the first rectangle that we worked with, 7 by 25, and I'm going to outline the small triangle, the 7 by 5 one, and do the same for the larger one, except I've combined the two smaller ones into a 7 by 20 rectangle. Obviously, these two rectangles have exactly the same area as the one larger 7 by 25 rectangle. So it should be 175 if we work it out in a different way. What I would like for us to do is to actually take those two rectangles and make one complex rectangle. So I want you to feel that there is one rectangle here made up of the two smaller ones. If each of those two sides is 7, then combined, it's going to be 14 along that side. The lower area, the lower leg, is going to have a length of 5, and the upper one is going to have a length of 7, since it's the same as the opposite side. The top rectangle has an area that we can calculate by multiplying 7 by 20, which is the same as 7 times 2 times 10. And we'll just annex a 0 to 14 to get 140. The lower rectangle is 7 times 5, which is 35. We now have two smaller partial products, 140 plus 35, the sum of which is 175. That's exactly the same as we found before when we multiplied 7 by 25 and got 175. So we've done it. First thing I want you to remember is if I'm going too fast, please slow me down by hitting pause, backing it up, and then replaying the part that's unclear to you. The next thing I want you to remember is at the very beginning of the video, I mentioned that you were going to do 2 practice problems. The first one was 9 hours at a rate of $50 an hour. And the second one, the challenge question, was 6 hours making $12.50 an hour. What I would like you to do is to pause the video, work those 2 problems out on your own, and then you can go to the description below and you can check and see if your answers are correct. What we know now is that if we have a complex shape, a larger shape, what we can do is break it apart into smaller, more manageable rectangles. When we find the area of the smaller rectangles, we simply then get the sum, and that gives us the area of the complex shape. The same thing applies if I'm multiplying larger numbers. I can break those numbers apart based on their place value, multiply each of those values by my smaller factor, and then add the partial products together to get a total sum. Helping Laura figure out how much money she was going to make by helping out in the library has helped us understand how to use an area model to multiply a 2-digit number by a 1-digit number. Hope that helps. Bye.
I'm ready for war, I'm coming for throats. To turn to a ghost, I need to know everything.